543, diameter of a binary tree. Given a binary tree, you need to compute the length of the diameter of the tree. The diameter of the binary tree is the length of the longest path between any two nodes on the tree. This path may or may not pass through the root. Okay. Given a binary tree, return 3, which is the length of the path, blah, blah, blah. Okay, let me think about this for a second. So let's say we have a node on, like, for every root, the current root node, we pass through this node is just the max of the left and the right, right? And then you kind of max through all the nodes where it makes a period, if you want to call it that. Is that good enough? I guess so. All right, let's do that then. The depth of the left was plus the depth of the right, and then that's your best. Okay, cool. Yeah, I was trying to be maybe a little bit fancy, but I think I could do it with what you call it, with a helper function instead. So say the current node. So this one just gets depth. Okay, left depth, say, is equal to depth node dot left. Also, we want to check if node is none, then just return 0. Yeah. Otherwise, right depth is equal to right. And then the value of this one is just left depth plus right depth plus 1 for the current node. And then that's pretty much it. I spent a lot of time the other day debugging because I forgot to kick off the depth first search, which was really unfortunate. But yeah. And then here, we actually just want to return the right depth. Whoops, typo. Also plus 1. So note that these two things are slightly different, even though they look very similar, because we want this function to actually return the max depth, where here we want to calculate the best answer. Maybe I'm off by 1 though. Why is expected answer 3? Because 4, 2, 1, 3 is 4, right? The length of the path and not the number of nodes. Okay, that's fine. Then we're just minus 1. Okay. Again, a little weak on the example test cases, but I'm a little bit confident. Again, with these 3 recursion problems, okay, fine. I didn't test empty node, but yeah, okay. Yeah, okay. So maxed up. I guess I didn't need this. And this would be okay. In a non-empty tree, this would be okay, but silly mistakes. Okay, let's submit again. Okay, cool. Hey, Tux11 and Sahanil. I hope I'm saying that way. Yeah, I mean, I think some of the earlier problems, they also don't tell you the constraints of the problem, so it's a little bit tricky because you're like, because half the times they don't have it, half the times they do have an empty case, and you're like, eh. And to be honest, I'm just a little bit lazy on an interview. I would just probably ask and then just look through it. But it is what it is. It's fine. At least I solved it quickly, I suppose, on a way silliness. But yeah, so this one, again, we look at each node only once. So it's O of n. We only use O of 1 extra space, kind of, except for these temporary variables that are allocated on a stack technically, but you don't really need it in theory. And technically it's O of n if you count the recursion recursive stack, then it's the O of depth, which is kind of O of n in the worst case for extra space. So O of n time O of n space. But yeah, otherwise, a straightforward, quote unquote, straightforward-ish recursion problem. I think there are two things that you have to kind of marry together, and then you have to figure out the implementation, which is sometimes a little bit tricky. You could have also done this, for example, with by returning a tuple. I kind of have a weird hybrid thing where I get the depth and then so forth. You could have also done this in two depth first search, where one just explicitly gets the depth of, you have to store it somewhere, but gets the depth of a given node, and the second one that kind of gets the best given that you already know the depth at those places. But generally pretty okay. And yeah, again, with recursion and stuff like that, I definitely advocate practicing, because people love, or interviewers maybe particularly, really like these type of recursion problems, and tree problems are kind of one the same, or they just illustrate an easy way for recursion to come up. So yeah, that's why I have for this problem. Cool. I think I missed a question.